Okay, so this is what, video number 4, is it? No more imports. I've made a slight change here by adding P1 color and P2 color, so I can refer to those and let the user change them here if they want to. Now I've added game over, which I use like I did last time. So right down at the bottom here, we've got game over equals false to begin with. And I'm going to show you how to draw all the pieces and check if a win has happened, and that's probably the most complicated bit of anything that we do. Drawing a piece is pretty straightforward. We're just going to loop through each row. The first thing that we get when we go through our grid is going to be a row, and then we want to get a particular column in that row, and that's why I said earlier on that it's YX rather than XY, but it's reasonably straightforward, I think. Enumerate numbers what you get back. So this here will, when we enumerate the grid, each item in the grid is a list of columns. It's a row, and a row is a list of columns. So each item is a row, and the number of it is either going to be 0, 1, 2, 3, 4, or 5. So that's what Y runs up to. And each time we go through this outer loop, Y will start off as 0 and then increment 1, 2, 3, 4, 5, and row will be the corresponding row. So the bottom row, the next one up, the next one up, the next one up. Okay. Once we've got a row, we want to go left to right across it, and X will be the column, so 0, 1, 2, 3, 4, 5, 6, because there are 7 columns, and the player piece I'm using here will be either a 0 if there's nothing there, or a 1 if the player 1's got a piece there, or 2 if player 2's got a piece there. And then this is really what we're going to do once we get there. If the player piece is 1, then we draw a piece using player 1's color at XY. And if it's 2, we draw a piece using player 2's color at XY. And that's sufficient to, when you add pieces, to get them appearing where they should appear. Okay. Now I'm going to, the big function here is get the winning line. It looks a bit scary. Let's just quickly get this grid up again, and I'll explain the way that I've thought about it. So I essentially do horizontal lines first, then vertical lines and diagonal at the end. If you look at where horizontal lines can occur, they can either start here and go 4 across, or start here and go 4 across, or start here and go 4 across, or start here and go 4 across. So I only need to check these grid locations. Okay, so I'm going to, for each one of these, I'm going to check to see if this cell is the first one of a row of 4 heading left to right. And I do the same with the columns, and I start at the bottom, I think, so I test only these. Okay, starting at the bottom and checking if upwards there's a row of 4, and I do that right the way up to this one here to check if there's a row of 4 up there. And then diagonals, you can see that the only diagonals that you can fit in, if they're going top left to bottom right, then they have to sort of start up here in this quadrant. So I only look at those ones. It's not possible to get a list of 4 diagonals anywhere else. And similarly, if they're going down top right to bottom left, I only check those. They're the only ways you can get diagonals. So I'll do this reasonably quickly just so you get the idea. There's no point in spending hours and hours on this stuff. So for each row in the bottom, for all of the rows, for each column in the first 4 columns, so I've got the left hand side, I'm looking at horizontal here, then I check that all of the, okay, let's work backwards. This gives us a list of all of the pieces, starting with the particular cell I'm on, which is row col, to the left +4. This is what's called a slice here. So I'm going from col, which is my starting cell, to col +4, which is 4 cells along. So it gives me a sort of subsection of the row, and I'm asking, is it true that all of this thing here, grid row col, equals value, and value is in this row. This is going to give me a true if they're all the same, or if the first value is the same as all the other values. Okay, so it's just a succinct way of saying the first value is the same as value, where value is each of the values heading left to right, in a row of 4. I also want to check that the value is not 0, because lots and lots of times, I mean, right at the start of the game, they will be all the same, but they'll be zeros. So I want to check that they're not zeros. This function here checks that every item in the list that it's been given is true. So it returns true if they're all true. Okay, so this says, is it, when we test whether the values in this subsection of a row are equal to the first value, only evaluate to true if they all are. And so that basically gives us a horizontal row. And what I return then is the coordinates of the pieces. So starting at col row, then I add +1 to column, which gives me the next one along, add +2 gives me the next one, and add +3 gives me the next one. So this returns the coordinates of each of the pieces in the winning line. That's why it's called get winning line. This does exactly the same, except I transpose the grid first, so that when I'm looking for my horizontal rows here, having transposed, I'm actually looking for vertical ones. You may remember what the zip function does if I've got parallel lists. So you can imagine lists on top of each other of the same length. It will sort of slice downwards and give me all the first values, then all the second values, then all the third values. Normally you would specify to zip exactly which lists you're talking about, but if there's a list of lists, you can use this syntax to just say all of the lists in this list of lists. So I'm transposing the grid here and doing exactly the same check. And then you can see with my diagonals, carefully, I'm starting at row col, and that changes for each of the cells, the grid cells, if you like, in the little subsection that I explained at the beginning. And here I'm decreasing row by 1 and increasing col by 1. So what does that mean? I'm going, I think, what does that mean? Up left? I think, no, increasing column, decreasing row. What is that? Down right. So I think these are down right. Yeah, it says down right. That makes sense. Okay. And this, I've got a much more explicit test here. It's quite simple for me to just check if they're all exactly the same. So if grid row col equals row -1 col -1, and it equals -2 + 2, and it equals -3 + 3, then we know that we've got a diagonal line, and I return it. And similarly here, I've got exactly the same, but instead of adding to col, I'm subtracting from col, so I'm still going down the rows, if you like, but I'm going left instead. If none of these things happen, if this return doesn't happen, and this return doesn't happen, and this return, then I get to do this, which is return nothing. It returns an empty line. So every single time I move, I check get winning line, and that might return nothing if the game isn't over yet. What do I do with that? I've got draw pieces up here. Oh yeah, that's right. In my update, which is where here, before, this is important, before I toggle the player, but after I've done whatever needs to be done to effect the move, I get the winning line and store it in winning line here. It may be empty because the game isn't over yet, so I check. If the length of it is equal to 4, then I know that I did get something from winning line. I set game over to equal true, and I'm going to print out the winning line here. Obviously, later on I want to sort of display it some way, but I haven't done that yet. What else do I need to do? Up here, I don't bother doing any of this update stuff if game over does get set to true here. So this allows me never to update again. And this one here, I need to add it to this list because I am changing the value of game over here. Is there anything else I need to show you? I can't. Don't think so. What else? I've added and not game over, so I'm only interested in mouse clicks if the game over hasn't happened. I'm not sure that makes any difference considering that the update doesn't happen anyway. I think that might be it. Let's try running it. Okay, so I can add pieces properly, and it's telling me what's going on here. Let's engineer a win for someone. So now when I click here, we should detect that there was a winning line and that player 1 has won. I can still, oh no, I can't still click because I've used that game over to prevent that. So all I need to do now is to display the winning line. I think the other thing that I noticed is that we can't tell whose turn it is, which is a bit hopeless. Let's just run that again. So I've got to put something in. If you've got a board that's rather full, it's quite difficult to tell that it's blue's turn in this case. So I've got to do something about that. Let's just check that the diagonal there shows that blue's won. But that'll do for that video.